All right, so here's the video for, this should actually say 9-7, 9-7, type 1 and type 2 errors. So when we reject this, or when we do a significance test, there's two possible decisions for our conclusions. We either reject our null hypothesis or we fail to reject our null hypothesis. We hope that whatever decision we make is correct, but however, sometimes we're wrong. Okay, so let's take a look at what it means to be a type 1 and a type 2 error. So here's a little chart that kind of helps explain what a type 1 and type 2 error. So on the side here is what decision you make. And then up here is what is the truth. So for instance, if you reject your null hypothesis, but your null hypothesis is true, you made a type 1 error, right? So if we have HO and we have HA, when we reject the null hypothesis, this is what we're concluding. Okay, but a type 1 error is when our null hypothesis is true. Okay, so we reject the null and conclude the alternative. However, the null hypothesis is actually true in real life. Okay. If we reject the null and the alternative is true, right? We reject the null and this is the thing that's true, then that's not an error, that's a correct decision. Okay, the opposite is when we fail to reject our null hypothesis, right? We fail to reject it, which means we have to cross off our alternative. However, our alternative is true. Right? So when we fail to reject our null hypothesis, we're basically, we're not really concluding that the null hypothesis is true, but we kind of are in a sense. That is a type 2 error, right? Because we chose the wrong one is what you can think of. Okay. If we fail to reject the null, but the null is true, then that's the correct decision. Okay. So this is kind of a visual to help you better understand what a type 2 and type 1 error is. So in words, type 1 errors reject the null when the null is true, and then type 2 is when we fail to reject the null when the alternative is true. It's a little bit easier to understand when you have an actual example. So let's look at an example. It says several cities have begun to monitor paramedic response times. In one such city, the mean response time to all accidents involving life-threatening injuries last year was mu equals 6.7 minutes. The city manager shares this information with emergency personnel, encourages them to do better this year. All right, so here are the null and alternative hypothesis, mu equals 6.7 minutes. If they're doing better, that means they have a lower response time. So that's why it's a less than, and mu is a mean response time to all accidents involving life-threatening injuries. All right, type 1 is when we reject the null, but the null is true. Okay, so when we reject the null, we conclude the alternative. So we need to write that out. We conclude that the mean response times have decreased Okay, so a type 1 error is when we conclude that they've decreased, but they really haven't. Okay, when you're interpreting a type 1 and type 2 error, there should be an error in it, right? You conclude that they've decreased, but they really have not. Okay, or you can say, but they really have either stayed the same or gotten slower. All right, a type 2 error is going to be the opposite. When we fail to reject the null, but the alternative is true. Okay, so when we fail to reject, we conclude that we don't have enough evidence for the alternative. So conclude we don't have enough evidence that mean response times have decreased, but they really have. Thing with about type 1 and type 2 errors is they're kind of opposites, right? So if we look at the first part of the sentence, we conclude the mean response times have decreased. The opposite of that is conclude that we don't have enough evidence that the mean response times have decreased. And the second part of the sentence is, but they really haven't, right? Response times haven't decreased. And then in the alternative, it's the opposite. Conclude that we don't have enough evidence that the mean response times have decreased, but they really have, meaning that the mean response times have actually decreased. So type 1 and type 2 errors should be complete opposite statements. All right, so I know it's kind of hard to write them out, especially when you're first getting used to them, and it's really easy to confuse them. So here's kind of a template with writing type 1 and type 2 errors. So type 1, we would say conclude HA when HO is true. And then type 2 would be the opposite. Conclude there's not enough evidence to conclude HA when HA is true. So again, complete opposites. Conclude HA when HO is true. Conclude there's not enough evidence for HA when HA is true. All right, so let's look at another example. So potato chip producer and supplier of potatoes agree that each shipment of potatoes must meet certain quality standards. If less than 8% of the potatoes in the shipment have blemishes, the producer will accept the entire truckload. Otherwise, the truck will be sent away. It isn't practical to inspect every potato in a given shipment. Instead, the producer inspects a sample of potatoes. On the basis of the sample results, the potato chip producer uses a significance test to determine to accept or reject the shipment. All right, so here's our null and alternative hypothesis, where P represents the proportion of potatoes that have blemishes. So type 1, we reject the null when the null is true. So when we reject the null, we conclude the alternative. So we conclude the proportion of potatoes in the shipment with blemishes is less than 8% when it's either equal to or greater than, or we can say when it's not. Okay, conclude the proportion of potatoes in the shipment with blemishes is less than 8% when it's not. So it's either equal or more than. And then a type 2 is going to be the opposite. Type 2 is we fail to reject our null when the alternative is true. So we conclude that we don't have enough evidence. So conclude we don't have enough evidence to conclude that we don't have enough evidence that, I'm just going to put the symbol, P is less than or equal to, or less than 0.08 when it really is. Meaning the proportion of blemishes in the shipment is less than 8%, but we're concluding that we don't have enough evidence to show that. Okay, so in each case for type 1, if we're concluding that the proportion of the potatoes in the shipment with blemishes is less than 8%, and we accept the shipment, right, we made an error. We're going to realize after we look at all the potatoes that there's actually more blemishes. So then we might have to throw the whole lot out. You end up, wasting time trying to produce the potato chips. And then a consequence of the type 2 error is if we're concluding that we don't have enough evidence that there's less than 8% and we send the potatoes away because it's not a good batch, because remember, a good batch has to have less than 8%, then we lose out on supplies to make potato chips. So we could, in the long run, lose money. So there are consequences to type 1 and type 2 errors. All right, here's the last one. So it's about the battery. So we have mu equals 30 hours and mu is greater than 30 hours, where mu is a true mean lifetime of the new Deluxe AAA batteries. So type 1, we reject the null when the null is true. So we conclude, so I'm just going to do this one verbally. We conclude that the mean lifetime of the new Deluxe AAA batteries is greater than 30 hours when it's not. And a type 2 error is when we fail to reject, but the alternative is true. So when we fail to reject, we conclude that we don't have enough evidence to conclude that the true mean lifetime of the new Deluxe AAA batteries is greater than 30 hours when it really is. So again, they should just be opposite statements.